agile software consultancy, so we get lots of projects in, and being able to rapidly deploy a DevSecOps environment is really important in order to take it through on our short-term projects. Also work as a security lead there, so in sort of like a bit of off time with projects, I sort of head up security for this company. And yeah, my LinkedIn profile is here if you want to chat. Cool. So today we're going to start off with an introduction to what DevSecOps is. We're going to take a look into the commercial solutions and then look into how we can make it cheaper with using open source software instead. And then we're going to analyze the trade-offs between using this open source software and the commercial products. So firstly, to sort of give a bit of a background of like why we want to implement DevSecOps, part of it is to get towards the shift left, which is implementing security measures earlier on in the software development lifecycle. The idea being that the earlier we check the security, the cheaper it is, and cheaper it is to fix, and therefore harder it is to exploit and victim intent. So a bit of an example on this is I worked on a client project where we didn't really do much security checking while we were making it, and we sort of got to the end of the project, we handed it off, and they went and did a penetration test, and they found a few issues, and then they had to rehire the team to actually come and fix them. And it's because we checked for it so late, ended up them spending more money in order to fix the issues. Another example is, I'm sure some of us have all seen pull requests a bit like this. And what do? We panic. You're going to have to rewrite your Git history, you're going to have to rotate your keys, and it takes a bit of time. You know, if you know what you're doing, maybe it takes like an hour, but, you know, it's still time wasted. Whereas if we have something set up like Git leaks, we're able to find this earlier before it even gets pushed to a remote version control system. So it will be blocked when you make the commit, and therefore you can spend way less time fixing it, and it's a lot cheaper. So next we're coming on to what is DevSecOps. And DevSecOps is creating a shared responsibility for security by embedding it directly into the software development lifecycle. So yeah, here we have the lifecycle of DevOps, so planning, coding, building, testing, releasing, deploying, operating, and monitoring. So in order to accomplish this embedding of security, we want to focus on adding automated security testing to each stage of the DevOps lifecycle. This will lead to security being an integral part of the development process, whilst also reducing the overhead for developers writing the code. This makes it easier to spot and to fix any security flaws that get introduced. And as we're aiming for the shift left in our security testing, I'm mostly going to be focusing on these 4 steps as part of this presentation. Now, we obviously don't want to be writing all of this automation ourselves, and in most cases, these are solved problems that there are companies out there that sell out-of-the-box solutions for it. Unfortunately, these can get quite expensive. For example, Sneak here, they charge $75 per user per month, and if you want the full package. And for a 10-developer startup, this is already going to cost $9,000 per year. To some companies, this might not sound like too much, but having worked with a lot of startups in my consultancy role, they quite often have quite limited budgets, and some of them will just not want to spend this on security when they're already dropping a lot of money on other SaaS products for the whole development cycle. So the solution to this problem is to use open source. I promise this is the last SpongeBob GIF in here. So yeah, open source is a huge part of the security community, with both homegrown community-led products and open source tools created and supported by larger companies. So being able to harness them to build our DevSecOps system is really important. Cool. So jumping into the first stage of the development lifecycle, we start with planning. So this is a stage where a lot of the big decisions are made on the technical strategy for the rest of the process. Making a mistake here can have big ripple effects to the remaining stages, but unfortunately it's also the least automatable. So the general strategy here is to analyze what threats there are and build up a plan on how you're going to mitigate them later on in the process. So there are a lot of frameworks we can use here, such as Stride, which is a model for identifying threats and looks at each of the potential types of attacks that could occur and helping you think and categorize about which ones are relevant and important to your system. Other tools that we can use are some from OWASP projects, such as the threat modeling cheat sheet. This will give you guidance into how you can generate threat models. And then you can use a tool like ThreatDragon, which helps you actually generate the diagram and keep up to date. So we have an example of that on the left here. And also what's really important at this stage is trying to encourage developer involvement as much as you can. because the developers are going to be the ones writing the code. They need to know what threats they're looking to protect against. And showing them the importance of doing this will increase their buy-in as well. So next we get onto the coding stage. So this is before anything's pushed up to remote. It's the developer just coding on their local machine. And here we want to introduce tools and encourage workflows that help developers avoid creating commits and pull requests that violate secure coding guidelines. So this stage will both involve educating the developers on secure coding, as well as providing automated tools that can be directly integrated into development environments. And this will help them catch vulnerabilities as early as possible before it's even pushed up to version control. So examples of things we can do here is secret scanning, as I showed earlier with Git leaks, to prevent any sort of secret keys being pushed up, and also doing static analysis security testing in pre-push hooks and in your IDE like this. This blocks vulnerable code from getting pushed to remote. So examples of tools we could use here are Git leaks as mentioned, but also something like SemGraph open source, which you can hook into your IDE to spot these vulnerabilities. This is an example of a vulnerability being shown directly into your editor. So you can hover over it, see what it is, get some advice on how to fix it, and hopefully the devs do that. So moving on to the build phase. So this phase occurs when the code has already been committed and pushed to a repository. So you'll often want to run these checks on PR open to alert the team to any new security issues before they merge into main or into staging. So here we can use lots of automated tools to look for common vulnerabilities, some of them quite similar to what we had in the previous step, but actually enforcing it on the pipeline level so that they can't sort of get around it by just -- no verify, which is the favorite of many people, I'm sure. So yeah, we have a developer pushing up to a version control system. Here we have GitHub. We can run secret scanning, run static analysis, security testing, and then run software composition analysis as well, which is something we'll get onto. So I've mentioned static analysis security testing, but what actually is this? So this is a white box testing method to help you find vulnerabilities in source code without like executing any of your code. So yeah, this is a really good tool to use to sort of catch the low-hanging fruit of vulnerabilities, but it also comes with quite a few challenges. If anyone's used it, they know it's just fills up with false positives and lots of warnings about things that you may have already mitigated against or decided it's like an accepted risk. And you want to make sure this isn't blocking lots of pull requests, because otherwise your developers will try and find a way around it. So ensuring you keep ignores and everything up to date and managed well is really important here. So again, a tool we can use for this, which I have up here, is using SemGraph open source. They have paid plans, but you can run it locally with the open source for free and therefore put it in a GitHub action. And it will sort of just run on your PR's opening. The downside to this is we don't get access to like dashboards and things like that. It will just be sort of like text in GitHub. So it's not quite as nice to use, but we do get the benefit of being free. Yeah. So next we have some software composition analysis, and this is an important part of managing third-party dependencies and open source components. It helps you track and analyze components being brought into a project, including their direct and indirect dependencies. They can then analyze potential vulnerabilities and exploits within them. So I've got a bit of an example of why this is important for a project that I've worked on. So we're building a Node.js app where we had multiple different packages, like our own packages we made, and they had to inherit each other as peer dependencies. So here, for example, we have a UI package and an auth package. What happened was we changed the name of the auth package to account. So when this happened, we also forgot to update the peer dependencies. So now whenever we ran yarn, it decided that it was going to look into NPM and try and find a package that matched auth. And this ended up with us installing this auth package, which has been downloaded 1,500 times and hasn't been updated for 11 years. And this was, it got to our staging environment before we caught this. So having good software composition analysis would have helped us catch this earlier. So how do we actually do this, especially in open source? We can use something like CycloneDX to generate the SBOM and then upload it to a tool like Dependency Track to get like a nice dashboard like this. So the downsides of this is we have to provision our own instance of Dependency Track to set it up, but it does give us a very like polished application with a nice dashboard and everything like that. Another tool we could use if you want to get it up and running a bit more, like a bit quicker, is something like depscan. You can just run this as a GitHub action in command line, and I found it really easy to set up. It's kind of just set it, you just leave it, and it kind of keeps checking for you. So yeah, it really handles it nicely, but it won't give you a nice interface like this. It will just be like warnings in your GitHub PR. Cool. So now we're on to the testing stage, which is the last stage we're going to look at in this talk. So this is targeting the build artifact once it's been deployed to a staging or testing environment. And the aim here is to simulate real threats and attacks that could occur on a production environment from real malicious users before they're able to be exploited on production. So the downsides of this is it's a lot longer to run, and more computationally heavy. So we may not want to run it always on a per push basis. I've often set it up with running sort of overnight, something like that where it doesn't run as often, but still alerts you quite often. And it's often best practice to try and set up a separate environment for it, just so you're not like constantly hitting your staging environment with lots of requests and like slowing it down and things like that. And yeah, there's pre-built actions that you can use if you're using GitHub, for example. I'm sure there are with like a lot of other CI tools. So here's an example of some alerts that you can get running an OAuth SAP scan, which is a tool I'd recommend from open source stuff. Yeah, so it gives you some alerts and you're able to have a look and fix these. So taking a look at some of these open source tools, we obviously have a lot of big savings here, but there are some missing pieces that we don't get by taking this approach. So we're not going to get out of the box combined dashboards where all your tools are together in one place and you get all the outputs together. You're going to have to like sort of hunt around your different, your PRs or your local environment to see these different reports. We also aren't managing a single dependency anymore. We're going to have like quite a few different bits and pieces floating around, but you're going to have to manage. You're not just installing or like purchasing one product from one vendor and using that. So you have to take that into account. And the last thing we're missing is dedicated support. So the open source community is very good at providing these support. So I'm sure if you went on Slack channels or GitHub issues, you'd get help when you need it. But it's not a guaranteed thing. You're not paying people for it, so it might not be as guaranteed, basically. So finally, just to put what we have together. So taking through the first 4 stages, we have our team generating the tech plan and generating a threat model. We have a developer writing code, doing local static analysis, security testing, and secret scanning. They then push to remote, where we do more secret scanning, more SAST, and then combine it with SCA. And then we're able to build and deploy to staging, and there we can run dynamic testing on the staging environment. So thank you for listening. Please reach out to me if you have any feedback or questions. But if we have time for questions now as well, that would be good. There's a link to my LinkedIn here. The QR code takes you there as well if you trust it. But yeah, thank you.
Any questions?
Thanks for the talk. Very good talk. Question regarding SBOMs. So SBOMs in concept are a fantastic thing for both, the dev teams and the security teams. But it seems like in reality, at least at the moment, they're not really widely used. Why do you think that is? And do you see that changing anytime soon?
I think partly it might be just due to the fact that there are other tools that kind of give you similar things without taking as much time to set up. Like people on GitHub, you just have Dependabot will just give you alerts, and maybe a lot of teams might think that's just enough, or just running npm audit, that kind of thing. But yeah, I'm sure there's a multitude of other reasons. I'm not too sure.
Hi, have you ever done any analysis on the cost difference between running an out-the-box solution and the extra time involved in people's resources having to piece these other systems together? Because you sometimes find that by the time that you've taken all that into account, the out-the-box system not only is slightly better, but it also can be cheaper.
Yeah, I think that's definitely a very good concern, and I think it probably depends on how much your company is scaling. Like if you're, the higher number of developers you have, the more that these out-of-the-box solutions are going to cost, because they're often on per developer basis. But at the same time, it might be worth the cost when you're a bigger company to make sure you get these rock solid tools instead. But yeah, I think I've never done an analysis on it, but I guess it really depends on the organization. Yeah.
Do you do the threat modeling throughout the whole process of development, or is it once at the start? And do you have any kind of preferences for threat modeling methods?
So it's definitely should be done sort of throughout the process, pretty much all the time, especially when you get new features in. You definitely need to do threat modeling there and then adjust it as your product evolves. Whether it always happens like that, who knows? Depends on your team. But yeah, in terms of processes, I'm definitely still working on that. I'm coming into a company that doesn't have like a great security posture, like a really mature security posture. So we're still trying to like work it out from there. But yeah.
So you mentioned the AWS API key leaked on a GitHub PR. What's your preferred method for password management within applications?
So it's usually using the sort of like built-in tools. So when I'm actually using passwords in an application, I'd probably use like something like SSM if I'm deploying on AWS. The actual API key on AWS, you're probably looking at using, I think it's like GitHub Secret Store or something, that kind of thing. I've also had projects where we sort of encrypted the .env and then actually pushed it onto GitHub, and then we can sort of share the password through like password managers. I don't know if that's the best approach, but it's something we've done before. Yeah.
Okay. Oh, no, one more. Last one. Yeah.
In the same example, you have shown a screenshot in which the push to the repository was rejected. So I assume that was done via pre-commit hooks, right?
So the Git leak, so you can run that on remote to sort of detect it when it's get pushed up, but you can also have a pre-commit hook that runs it and it'll check your commits that you're pushing. Yeah.
Okay. In that example, Git leaks was configured at GitHub before it actually merges the push, right?
So it detect it and block it before you actually push it up. Yeah.
So it was done on the developer machine?
Yeah, on the developer machine, sorry,
Okay.
yeah.
So
you
it
can
requires...
kind of get it in both cases, but yeah, I'd recommend having it on pre-commit and probably also in your GitHub.
Okay, got it.
So,
yeah. Thank you.
Well, should we say thank you again?
Thank you.